Hi, welcome back, and here's our next tutorial on molar mass. So we're going to be applying some things we've already learned to a new concept. If you look at your periodic table and view the average atomic mass for any element, if we consider that mass in grams, we can call that mass the molar mass. So the molar mass we can think of as the average atomic mass in grams. It's also the mass of 1 mole of a substance. For my class, we will be rounding up to the nearest tenth from the mass shown on the periodic table. There are some variations in average atomic mass from periodic table to periodic table, but if we all round to the nearest tenth, then we should come up with the same molar masses. So for instance, if we look at hydrogen, its molar mass to the nearest tenth would be 1.0 grams. Carbon, 12.0 grams. Lithium, rounded to the nearest tenth, would be 6.9 grams. Sodium, rounded to the nearest tenth, would be 23 grams. Oxygen would be 16.0 grams. Calcium, 40.1 grams. Okay. So let's say that we are in the laboratory and we know that we have 3.1 moles of calcium. How many grams of calcium do we have? Well, again, we can set up a conversion factor. This time, grams is going to go in the numerator. Remember that the units we convert to goes in the numerator, so we're converting to grams. Mole then would go in the denominator because we want moles to cancel out. What value is going to go up here in the numerator? It would be the molar mass of calcium. So this value here would be the molar mass. And in this case, calcium, because that's what we're working with. And the molar mass of calcium is 40.1 grams. And we would put that over 1 mole. So this becomes a multiplication problem. So we'll have 40.1 grams times 3.1. And we'll get 124.3 grams of calcium. Now, if we're expressing this to significant digits, remember that we only have 2 significant digits here. So rounding this to 2 sig figs, I know it's been a while, this would round to 120 grams of calcium. If we're in the laboratory and we measure out 111.7 grams of carbon, how many moles of carbon would that be? So we use a conversion factor. This time, moles is going to go in the numerator because we're converting to moles, and grams will go in the denominator. So we'll have 1 mole here. This value is going to be the molar mass of carbon. And that value would be 12.0 grams. So our problem becomes 111.7 divided by 12.0. And we would get 9.308 moles of carbon. And this is rounded to 4 significant figures. We can also find molar masses for compounds. So if we have the compound water, H2O, in order to find the molar mass, we look at the formula and we can consider that this here would be equal to 1 mole of water, which is 2 moles of hydrogen and 1 mole of oxygen. So this is 2 moles of hydrogen plus 1 mole of oxygen. Okay, 2 moles of hydrogen is going to equal 2 times the molar mass of hydrogen, which is 1. And 1 mole of oxygen is 1 times the molar mass of oxygen, which is 16. So we end up with 2 plus 16, which is 18 grams. If we want to find, for instance, the molar mass of calcium oxide, this would equal 1 times the molar mass of calcium, which is 40.1, plus 1 times the molar mass of oxygen, which is 16. So we have 40.1 plus 16, and this equals 56.1 grams. If we want to find the molar mass of calcium carbonate, this will equal 1 times the molar mass of calcium, which is 40.1, plus 1 times the molar mass of carbon, which is 12.0, plus 3 times the mass of oxygen, which is 3 times 16, which is 48. And we end up with a molar mass of 100.1 grams. So not only can we find the molar mass of any element by looking on the periodic table, but we can also find the molar mass of any compound by calculating it using the molar masses of the elements. Now what we're going to do in the next tutorial is apply this to some problems with compounds. Okay, welcome back. And we're still continuing our work with molar mass, and we had just learned to calculate molar mass of compounds. And so now we can do some really interesting problems with this. So let's say that we have 231.5 grams of calcium carbonate. I want to find out how many moles of calcium carbonate I have. I can set up my conversion factor. Moles is going to go on the top, 1 mole, grams will go on the bottom. And this will be the molar mass of calcium carbonate, which we had just calculated to be 100.1 grams. So my problem becomes 231.5 divided by 100.1. And I get 2.313 moles of calcium carbonate. Remember that we went around to the proper number of significant figures here. We can go the other direction. So if I have 5.57 moles of water, how many grams would that be? This time grams will go in the numerator and moles will go in the denominator. My molar mass of water is 18.0 grams. So my problem becomes 5.57 times 18. And this becomes 100.26. We have to round to 3 significant figures, so this will round to 1.00 times 10 to the second grams of water. We need to put this in scientific notation in order to have the proper number of significant figures. Now we can also do some really interesting problems with this. If we think about molar mass as being a link between measuring mass and counting particles. So obviously we know we can't count atoms or molecules or formula units. They're way too small, but if we can measure the mass of something, we can find how many particles are in that something. So it's actually kind of exciting concept to think about. If I go in the laboratory and I measure out 231.5 grams of sodium chloride, how many ions of sodium and chloride would I have in that sample? Well, I can use molar mass to figure this out. So the key is first I need to convert to moles. So I use the molar mass of sodium chloride. That is calculated as 58.5 grams. I've added the molar mass of sodium, which is 23.0. Chlorine is 35.5 to get 58.5 grams as my molar mass. So now I'm in moles. Since I'm in moles, I can now convert to representative particles of the substance. A representative particle of sodium chloride is a formula unit. So how many formula units are in a mole of a substance? 6.02 times 10 to the 23rd. Now Avogadro's number is coming back into play. Anytime we're dealing with the number of particles in a mole of something, the number of particles, we use Avogadro's number. Okay? Number of grams is molar mass. Okay? So this number of particles, we use Avogadro's number. Number of grams, we use molar mass. Keep that in mind, because when I see students work problems, a lot of times, or I can't believe how many times I'll see students write in a conversion factor of 6.02 times 10 to the 23rd grams. No, it's always 6.02 times 10 to the 23rd particles, whether it's formula units, whether it's molecules, whether it's atoms or ions. So now we've converted to formula units. We want ions. How many ions of sodium chloride are in one formula unit? Well, the formula tells us there's one ion of sodium and one ion of chloride. So we have 2 ions per every one formula unit. So our problem becomes 231.5 divided by 58.5 times 6.02 times 10 to the 23rd times 2. And we end up with 4.765 times 10 to the 24th ions. So I've been able to calculate the number of particles just by measuring grams. Okay, that's pretty cool. What if I I'll just throw this number out here. Let's say I have 7.7671 times 10 to the 25th atoms in a water sample. I want to know how many grams of water I have. Now, essentially, I'm working backwards. So I have atoms. In order to go to grams, I have to convert to moles. Moles is my link here. So I'm converting 1 mole. Hold on a minute. First thing first, I made a common mistake. Maybe you figured out what mistake I made. But atoms is not the representative particle for water. Molecules are. So the first thing I need to do is convert to molecules. I need to convert to representative particles first. It's early in the morning, or early enough anyway, and my brain's not working. So how we need to convert to molecules. Atoms is canceling out. How many atoms of H2O, how many atoms do we have in one molecule? We have 3, 2 hydrogens, 1 oxygen. So now I've converted to molecules. Now, since I'm in representative particles, I can convert to moles. Okay, so moles will go on the top, molecules will go down here. We have 6.02 times 10 to the 23rd molecules in a mole. This is where I have Avogadro's number here. Avogadro's number. So I'll circle that in green to make it follow with this step up here. All right, now since I'm in moles, now I can go to grams. there are 18.0 grams in 1 mole of water. So my problem is 7.7671 times 10 to the 25th. I'm going to divide by 3. Then I'm going to divide by Avogadro's number, 6.02 times 10 to the 23rd. And I'm going to multiply by 18. And I end up with 774.13 grams of water. So now I've been able to go from number of atoms and work my way all the way back to mass. Okay, moles is the link. Moles is the link. Moles is the link between mass and particles. Just like I wrote at the top of the page, I'm rewriting it. So we have to convert to moles. That's kind of the central thing here in every problem. I've circled it in green here. Converted to moles here. Here we've converted to moles. Okay, that is the central link between measuring mass or finding mass and finding the number of particles.